In this video, we are going to continue with the more concept. Now, this time, we are going to look at some other ways in which we can calculate the number of moles given mass or volume or concentration. So now, we can begin by first discussing what molar mass is. So, molar mass is defined as the mass of one mole of atoms, molecules, or formula units measured in grams per mole. So let's say we have a covalent compound such as water. So from there we can find the relative molecular mass. So here we can say we have 2 atoms of hydrogen, so hydrogen times 2, plus 1 atom of oxygen, so oxygen multiplied by 1. The mass number for hydrogen is 1 multiplied by 2, plus 16 times 1. So 1 times 2 is 2, plus 16 times 1 is 16. 2 plus 16 is 18. So this 18 represents the relative molecular mass. Now, if we just add the grams per mole, so if this 18 becomes 18 grams per mole, this now becomes what we call the molar mass. So the difference between the relative molecular mass and the molar mass, relative molecular mass has no units, while molecular mass is measured in grams per mole. So now we can see that from the chemical formula of water, we are able to see that 1 mole of water has 18 grams. So this is what it means is, so we have 1 mole of water has 18 grams. So this is what now that is what we call the molar mass. Now from there, let's look at the first formula that we are going to use in order to calculate the number of moles given the mass. So the formula is number of moles is equal to mass divided by molar mass. So now in terms of initials, the symbol for number of moles is small letter n, for mass is small letter m, then for molar mass it is mm. Or in some books you may find it number of moles is equal to mass. Now the other symbol also you may encounter is capital letter m. So capital letter M sometimes may also represent the molar mass. So now you can find the number of moles given the mass and make sure that mass should be in grams. So if you have maybe given mass in kilograms, don't forget to convert that mass into grams. So now let's first now have some examples. So the first example is find the number of moles in 0.21 grams of copper. So now if we go on the periodic table, we have the mass number for copper, depends with the periodic table that you are using. So if you are using a periodic table where we have mass numbers in all numbers, you may have this 64. Then in some periodic table, you may have 63.5. So now here, we are just dealing with a pure element. It's not a compound. So whenever you are dealing with a compound, here we are not going to find the relative formula mass. We are going to just find the relative atomic mass since we are just dealing with a pure element. So here the formula, we have number of moles is equal to mass divided by its molar mass. So we are going to look at the molar mass for copper. So now we can say number of moles is equal to, the mass is given from the equation 0.21 grams, then divided by its molar mass. So let's first find the relative atomic mass. So the relative atomic mass is 64. Now its molar mass. Now its molar mass, we just add grams per mole to 64. So 64 grams per mole now becomes the molar mass. So now we divide by 64 grams per mole. So you can see that the gram and the gram can cancel. So we can now divide 0.21 divided by 64. Then we have 0.003 moles, or 3.28 times 10 to the power negative 3. So we can now just use the decimal one. So 0.003 moles. So this is how you can find the number of moles given the mass of an element. Now let's also have another example. Okay, now let's move on to example 2. Calculate the number of moles in 200 grams of magnesium oxide. So here the symbol for magnesium is Mg. Magnesium has a valence of 2. Then for oxide, which is oxygen, is O. Then also it has a valence of 2. So if we cancel, we can see that magnesium oxide has a 1:1 ratio. So we can see that there is 1 atom of magnesium and 1 atom of oxygen in a compound of magnesium oxide. Now this magnesium oxide is an ionic compound since it consists of a metal and a non-metal. So therefore we are going to find its relative formula mass. So let's first begin by finding the relative formula mass. So we can say Mr is equal to, so we can see that magnesium multiplied by 1 plus oxygen times 1. So the mass number for magnesium has a mass number of 24 times 1 plus 16 multiplied by 1. 24 times 1 is 24 plus 16 times 1 is 16. So 24 plus 16 is 40. So this is our Mr. So therefore we can now say molar mass is equal to 40 grams per mole. So now we can see that we have found the relative formula mass of magnesium oxide. Now let's proceed to look at, now we find the number of moles of this magnesium oxide. So we say number of moles is equal to mass divided by its molar mass. So from the equation we can see that the mass is 200 grams, then divided by the molar mass 40 grams per mole. So gram can cancel, number of moles is equal to, so 200 divided by 40, we have 5. So there are 5 moles in 200 grams of magnesium oxide. So now we move on. We have the third example, calculate the number of molecules. So now here we can see that we are calculating the number of molecules in 200 grams of carbon dioxide. So let's look at the formula for number of molecules. So number of molecules is number of moles is equal to X. Our X represents the number of molecules or number of atoms or ion, depends with the need of the question, divided by the Avogadro's constant. So over 1, we cross multiply so that we can make X the subject of the formula. So X is equal to number of moles multiplied by the Avogadro's constant. So from there we can see that we have been given the mass. We have been given the mass of carbon dioxide, but from the formula here we can see that we need the number of moles. So let's find the number of moles by using this mass. So we can say number of moles is equal to mass divided by the molar mass. So let's first now write the chemical formula for carbon dioxide. Carbon dioxide is CO2, but let's just use the rules. So carbon has a valence of 4 oxygen has a valence of 2. So if we cancel, 2 into 2 is 1, 2 into 4 is 2. So we can now interchange. The 2 will go here, then 1 will go here. So we have this chemical formula of a carbon dioxide. Now, carbon dioxide is a covalent compound because it consists of nonmetals. So we are going to find now the relative molecular mass. So we'll say Mr. is equal to carbon times there is 1 atom of carbon plus oxygen times 2. So the mass number for carbon is 12 times 1 plus 16 times 2. 12 times 1 is 12 plus 16 times 2 is 32. 32 plus 12 is 44. So therefore the molar mass is 44 grams per mole. So we have the molar mass. Now we can proceed by finding the number of moles. So the number of moles is the mass is 200 grams over the molar mass is 44 grams per mole. So now 200 divided by 44, so we have about 4.5 moles. So these are now moles of carbon dioxide. Now since we have these moles of carbon dioxide, now we are going to substitute number of moles into this formula. So X, which is the number of molecules, is equal to, so the number of moles is 4.5 multiplied by the Avogadro's, it's a constant number, 6.02 times 10 to the power 23. So X is equal to, so now we can do 6.02 times 10 to the power 23. So we have about so 6.2 9 times 10 to the power 5 molecules. So we can do it like this, or maybe the other way, if you just want to do it at once, we can just say X is equal to number of moles multiplied by the Avogadro's constant, where we can replace number of moles with mass over molar mass. So where there is number of moles, we can just say mass over molar mass times Avogadro's, where the mass is 200 grams divided by its molar mass. Its molar mass is 44 grams per mole times 6.02 times 10 to the power 23. So if we finalize, we are going to get the same answer, 6.29 times 10 to the power 5 molecules. Okay, now let's also have another example, question 4. Now this time we are calculating the mass given the number of moles. So here we have number of moles is equal to mass divided by the molar mass. So over 1 times m is m. So if we are calculating mass, we need to multiply the number of moles multiplied by the molar mass. So we can see that we have 3 moles of sodium chloride. Then we can also find the relative formula mass of sodium chloride. So here we can see sodium is in group 1, so it has a valence of 1. Chlorine is in group 7, it also has a valence of 1. So the chemical formula for sodium chloride is this, where there is 1 to 1. So we only have 1 atom of sodium and 1 atom of chlorine in sodium chloride. So we can now find the relative formula mass. So Mr. is equal to sodium times 1 plus chlorine times 1. The mass number for sodium, we use 23 multiplied by 1 plus 35.5 times 1, which is 23 plus 35.5. So 23 plus 23 plus 35.5 is 58.5. So this is the relative formula mass. So therefore molar mass is equal to 58.5 grams per mole. So now we can substitute this into this formula. So the number of moles is 3, then molar mass is 58.5. So 3 times 58.5, we have 175.5 grams. So since we are looking for mass, we have grams. Okay, now let's move on now. Let's look at how we can calculate number of moles given the volume and also the condition. So here, what we are saying is we are looking for now molar volume. So molar volume is defined as the volume occupied by 1 mole of gas. So what this means is there are 2 conditions that we need to have in mind. The first condition is what we call standard temperature and pressure. So in symbols you may find it to be STP. Then the other condition is room temperature and pressure. In initials, RTP. So whenever you see these symbols, this is what they stand for. Then we are going to, let's say there are some figures that we need to have in mind whenever we are dealing with the molar volume. So first let's look at what it means by the temperature when the temperature is standard and when the temperature is room temperature and pressure. So from there we'll begin with the temperature. So in Kelvin, the temperature at STP is 273 in Kelvin. Then in degrees Celsius is 0. So 0 degrees Celsius, because we know that for us to convert from degrees to kelvins, we add the given temperature in degrees plus 273. So when the temperature is 0 degrees Celsius, that is a standard temperature. Now the pressure of a gas at STP is 1 atmosphere. Then the molar volume is 22.4 cubic decimeters. So that is the condition. So whenever you have a question where you have maybe given a question, calculate the number of moles of a given gas. Maybe if the question is under STP, you need to know that the molar volume is 22.4. Now let's look at now the condition where we have room temperature and pressure. So when the temperature is at RTP, in degrees Celsius is 25, then in Kelvin is 298. So 298 in kelvins. Then for under room temperature and pressure, that is 25. So if the temperature is at 25 degrees Celsius, that is the room temperature and pressure. Then the pressure of a gas is also 1 atm. Now the molar volume at this condition is 24 cubic decimeter. So these are some of the basics that we need to have in mind whenever we are dealing with the molar volume. Now the formula in order to find the number of moles given the volume and the condition is, so we can now say number of moles is equal to volume of a gas divided by molar volume of a gas. Okay, so the symbol for number of moles is small letter n. Volume of a gas is V over molar volume. Okay, now let's have some examples. Okay, now let's have an example. Calculate number of moles of the first party, 50 cubic decimeters of ammonia gas at RTP, B 200 cubic centimeters of oxygen gas at STP. So the formula, we know that the formula is the number of moles is equal to volume divided by the molar volume. So from the data, the part A, we are solving the first party. The volume is 50. So we have 50 cubic decimeters divided by. Now for the molar volume, we are going to look at the condition. So the condition is RTP. So if you have the condition of RTP, the molar volume to use is 24. So we divide by 24. So 50 divided by 24. So we have 2.0833. So 2.08 moles. So this is how you can calculate the number of moles given the volume. Then let's also look at part B. So part B, number of moles is equal to volume over molar volume. Now let's look at the volume. This time the volume is given in centimeter cubic. So there is a need of converting from centimeter cubic in decimeter cubic. So remember that the volume must be in cubic decimeters whenever you are dealing with the molar volume. So now we are going to use the conversion factor. So the first conversion factor that I'm going to give you so that you may use it to remember is 1 meter cube is equal to 1000 decimeter cubed. Then 1 decimeter cubed is equal to 1000 cubic centimeters, which is also equal to 1 liter. So 1 decimeter cubic is equal to 1 liter. 1 liter is equal to 1000 cubic centimeters, which is also equal to 1000 milliliters. So therefore we need to convert. So what we are going to do is we are going to say 1 decimeter cubic is equal to 1000 cubic centimeters. Then this 200 will be here, so we have 200 cubic centimeters. Then x cross multiply, so 1000 times x we get 1000 cubic centimeters x. Then here we have 200 cubic centimeters multiplied by decimeter cubic. So we divide by 1000. Then here also divide by 1000. So x is equal to, so 200 divided by 1000, we get 0.2 cubic decimeters. So what we are saying is if you are converting from decimeter to centimeter, you divide, you multiply, then from centimeter to decimeter, you divide. So what we are saying is 1 decimeter is equal to 1000. So from decimeter to centimeter, you multiply by 1000. From centimeter to decimeter, you divide with a 1000. So therefore we can now say number of moles is equal to the molar volume is, now this time we have been given a condition of STP, so standard temperature and pressure, so we are going to use 22.4. So whenever you have been given a condition of STP, you use 22.4 divided by 0.2. So now 22.4 divided by 0.2, we get 112. So 112 moles of oxygen gas at RTP, at STP. So now, so for this video we are going to end here, but there are so many examples and tasks, so you can look for other examples so you can try how far you can do. So that's it for this video. Thanks for watching. Subscribe to my channel and please never forget to hit the notification bell so that you are notified anytime I post a new video.